I realized earlier when I checked the tubes I never finished, and I hadn't checked some of the tubes on the front and a few of the 6SN7s tucked around in the back. And wouldn't you know it, 2 of the 6SN7s were really, really weak, like deep into the red. And when I was swapping them around, I might have just been swapping bad ones back and forth. So that may have fixed both the collapsing vertical issue and why I had to crank up the horizontal peaking so much. So I may have to turn that back down. I'll tip this on its side and check the waveform again. And I also found a couple 6AU6s in the IF that were a little weak and replaced that. And a 6AL5, half of which drives the relay. Well, what do you know? That half was pretty worn out. Not dead, but I went ahead and replaced it anyways. It's crazy looking at this now with the CRT out, where they put some of these adjustments, like there's one down in there, which has got to be delightful to try to adjust when the set's powered up with the full-size CRT in there. And there's another one there. And the peaking one I've been adjusting is over here. Not the easiest set to set up. Oh yeah, that's the damper tube. That'll be, oh, what do they call it? That's the peak. Oh, that's the horizontal damping control. And linearity's got to be around in there somewheres too. But that's the big 25-watt wire wound one. So I noticed we have what appears to be ringing in the horizontal. So some of that stuff needs to be adjusted to eliminate that. We'll get more to that when we get, I think, a test pattern on the screen. All right, now here's the other fun challenge with this. I've been complaining about the service info on this set. Well, here's another problem. There's no tube chart. There is no tube chart. So I can see why somebody wrote on the chassis what some of these tube designators are, but they didn't do the tubes up front. In particular, along in here, we have 1, 2, 3 tubes. 2 of them are 6BA6s. One is a 6AU6. I didn't take note of it when I pulled them out to test them. Now, 2 of them are the FMIF, the BA6s, and then there's a limiter, the 6AU6, so I'm pretty sure it makes sense that these 2 would be the BA6s and that'd be the AU6. They look very similar. They have the same pinout. They're not exactly interchangeable in terms of specs, but it'd probably work well enough that it wouldn't be at all obvious if I got it wrong. So I'll have to check the wiring down below and make up my own tube chart. There might have been one in the cabinet at some point that fell off, and maybe it's on the back, which I don't have. But man, what a fundamental thing to leave out of the service info. Okay, I think I got all the tubes back in place to the best of my ability. The 6V6, I double checked it and it is good. So, yeah, another odd thing. So I'd mentioned that all of these tube sockets are held in with screws. Big old Phillips headed screws. When you put the tubes in, the tubes don't go down all the way because the base of the tube bumps into the screw head. What a goofy thing. Well, I realized I never did complete testing all the tubes, so I went back through and completed that and found a couple of 6SN7s that were really weak. They were deep into the red territory. So I went ahead and pulled all, I think there's 5 or 6 6SN7s altogether. See 4 of them down in here. And double checked them all and made sure they're all good. And I hadn't done the 3 tubes up front here, and I hadn't finished doing all the IF tubes. So when I did so, I found a couple 6BA6s in the FMIF that were marginal, and a couple 6AU6s in the video IF that were marginal, and finally the 6AL5 dual diode, the half that drives the relay, was a little worn out, so that got replaced as well. So let's fire this back up. I'm hoping this will resolve the vertical collapsing issue, and I suspect I will need to adjust that horizontal size and peaking again. Hey, whoa, yes, we definitely made a big difference. Not only do we not have vertical collapse now, but it's really filling the screen. I had the brightness turned up pretty bright. Actually, that's about the same as it was before. So while doing all this, I've been complaining about the lack of good service info. There's one other key thing missing from the service info. There's no tube chart. So, for example, on the front, there are two 6BA6s and a 6AU6. I pulled them all out to test them and not noting exactly what went where. I just kind of figured out, like, that's first IF, second IF, discriminator, so just going by functional blocks what tubes go where, but geez, maybe it was originally on the back of the set, which I'm missing. It's not inside the cabinet. So I can see why somebody wrote on pencil, on, at least around some of the tubes, what did what. I'm adjusting that horizontal peaking now. I got ringing on this side. There's some vertical lines that shouldn't be there. Ah, crap. Okay. Boy, I really would have thought that replacing some tubes that were testing so deep in the red would make a difference. No, it didn't. It's funny. Just like you say, it's always the caps. It's rarely a tube. Tubes can test so bad and still function in the circuit well enough. Like the 807 that tests pretty miserable, and I repaired the cap. It seems to be working okay. Alright, so it seems like as something heats up in the vertical circuit, it craps out. So we're going to have to tip the set on its side. We're going to look at the waveforms. We got voltages we can check, and we're going to go over the vertical. We got to fix that really before we can do anything else, because we can't have that image collapsing. I'm not really worried about damaging my beat up little test CRT here, but I would not want to burn a line into the real deal. Been doing some poking around with my little handheld scope and determined a few things. One, half of this 6SN7 is a vertical oscillator, and this 6SN7 is vertical output. Two stages are coupled by this capacitor. When the vertical collapses, the oscillator is still running, but it seems like the problem is related to this tube. These three control shafts are all related to the vertical circuit. Since the service info does not include a diagram showing what controls do what, I've started to trace them out and write in pencil on the front here what they do. So this is vertical linearity, vertical hold, vertical size. Now once, when it was collapsed and I manipulated the vertical linearity control, I got vertical deflection back briefly, and then it went out again. I've tried manipulating this a few times and I can't get it back. Well, I looked at the circuit and how does that vertical linearity control work, and this reminds me very much of the Philco Predicta, which has a really common problem of losing vertical deflection because the vertical linearity control goes bad, and this has the same design where the vertical linearity control is a variable resistor in series with a fixed resistor going to the cathode on the vertical output stage. Why do I call that a flaw? Because if anything happens with this pot, there's nowhere for the electrons to go and you lose vertical deflection. Like if there's a dirty spot on it or a mechanical failure of it, you lose vertical deflection, burn a line into the CRT. They have that control signal coming from the horizontal deflection yoke, and if that horizontal deflection signal is low enough amplitude as we've seen, it kills the high voltage. There is no such protection if the vertical deflection goes out. It will still keep running. Eventually it would burn a horizontal line into the CRT. Alright, so the first thing I'm suspicious of is the fixed resistor and this variable resistor, so let's make sure we've got continuity there. What's a workaround for that? Well, what I've been doing on Predicta is I put a fixed resistor in parallel with that variable resistor of such a value that you can still control the linearity, but if the pot goes open, there's still a path for the electrons and you still get some vertical deflection. Alright, so let's go over this. Another thing I thought was a little odd is it sure looks like there's a 2.2 meg resistor in here, but the service info shows a 2.7 meg. It's original, so I'm not, maybe it's a design change or some such. It's not a huge difference between the two, but it kind of jumped out at me. Now there's another issue lurking, which is I don't seem to have any reception. When I got the raster, you may have noted there was no snow. I since tried feeding a test pattern generator signal through the antenna terminals, and I wasn't able to pick anything up. However, we know the FM receiver is working, which uses the same tuner mechanism. My next thought went to, well, hey, what about the detectors? So this set uses a 1N34 diode. Even though this set was made in 1947, that diode was first marketed by Sylvania in 1946, and this is a Sylvania, the very early type, which is a large white ceramic cylinder. However, I disconnected one end of it, and it tests okay. I do intend to replace it with a newer one because they were just figuring this stuff out back then, and I don't really trust it. But there's something else we're going to do right now, which is inject. So I'm using the video out of the TVA92, this guy underneath, companion to the VG91. You can do up to 300 volts peak to peak out on a video signal, and I've got that clipped in with the DC blocking capacitor here, going right to the output of that diode, which goes right to the grid of the video amp. It's a very simple system on this. Just a one-stage video amp. So you have video detector and 1N34 going right to the grid of the 6AC7 video amp, and that drives the grid on the CRT. More typically you'd see two stages for a higher end set, but oh well. And then there is a DC restoration circuit using half of a 6A05. So I'm going to inject a signal right here at pin 4. And let's see if we can get anything on the little test CRT. Now, I got this all tipped on its side, so we can't really see that too well. So I'm also hooking up the little pocket oscilloscope to that same point, so at least we can see what waveforms going in to the tube and what's coming out. So I'll put the probe on the grid side, and then we'll put it on the plate side. And I'm going to use a staircase pattern on my TPG because that is an easy one to recognize. Alright, so we should see. There we go. So that is what I'm putting into the tube. Let's turn the set on now and see what comes out of it. I'll switch the scope to the output side. Okay, we got a staircase coming out. Cool, looks like it inverted it. Okay, so what do we have on the CRT now? Okay, that's good. We are definitely getting something coming through. We don't seem to have a good lock on that. So let me fool around a little bit. It doesn't have a horizontal hold on the front of the set. I have to adjust that coil on the transformer. That guy up there. That's easy to do. So I'm going to concentrate on doing that, and I'll adjust the vertical hold, which is this guy right here. So none of these controls have knobs on them. They're not readily accessible, which you typically do. There's a horizontal and vertical hold are usually right out in front of a set with knobs on them. But my thinking is, Dumont designed this set so well, it's supposed to be a high-end set, they wanted to have a minimum number of controls. So they're not readily accessible. When you would get this installed in your high-end home, and you'd pay your installer to set everything up, so that ideally you'd never have to make any of these adjustments, at least not for a while when the set was new. You would just have these, which is mode, volume, tone, brightness, and contrast. I switched to a different test pattern because I was having trouble figuring out what the right polarity was. Now I got that right. but the hold is not working very well, obviously. Slowly scrolling horizontally, vertically. Horizontal is a little bit twitchy too, but hey, it's nice to see something, that's for sure. Okay, now this is funny, at least to me anyways. I disconnected all my stuff when I wanted to try going back to the tuner. I looked over at the screen and I thought I was going crazy because I'm like, I just disconnected the direct video injection. How could I possibly be seeing anything? Not realizing I still had the antenna RF input hooked up. So I think when I was doing a direct injection, I was fighting the signal coming in through the antenna with my direct injection signal. So anyways, we know the tuner works. And if you recall, when I was tuning in the radio, I would get crackles and staticky things. And I'm kind of getting that with the video too when I tune it, where I get bright flashes and stuff. I think we really got to get in there and clean that tuner. But hey, that's cool. So, I mean, just we know the entire tuner IF detector video amp chain is doing its thing. I think what we got to work on now a little bit is the sync separator. A pretty wide tuning range too, so I'm on channel 6 now, which as I'm doing this, pretty wide range. And if you look at this, let me flip this down. It's kind of interesting. So you notice how close together 6 and 5 are, then a big gap to 4, and pretty generous spacing around it. 3 is a little bit closer to 4, then a big gap to 2. And then we keep going and going and going, a big, big, big gap. And then at the end, there is, yes, this does have channel 1. So it seems this induct tuner is not very linear at points. The channel spacing isn't entirely perfect either. The gaps between channels are sometimes a little bit larger than others, but it's not that dramatic. I think that the tuner just has kind of some quirks to it. So try doing channel 3. I always try to focus on channel 3 and 4 because so many RF modulators put out signals on channel 3 and 4. So let's go with this. And yeah, see I'm actually closer to 2 than 3, but I'm already picking something up. So as somebody pointed out to me, when I was questioning the value of having a tuning indicator, he said, hey, look at where this signal strength signal comes from. It comes from the sound circuit, not the video. See, we're getting video over a very wide range, but the audio is going to be a very small point. Split carrier set, of course. And yeah, I am outputting a test tone. So what you want to do when you're tuning this is get that for that maximum deflection. That's going to be where you get your best sound. We're not getting a huge. Oh, there we go. The curious thing about that is, where are we at on the dial? We're about channel 2. What am I feeding in? Channel 3. Now this could also be a quirk of my RF generator, especially with cheaper RF modulators. They don't necessarily suppress sidebands so well, or in the harmonics, so we got to be careful about that. But as I also noticed with both the AM and FM, the tuning dials seem to be off, so it could very well be off for tuning in television as well. What I want to do next is disconnect some of my remaining leads here and flip this thing back down. Be a lot easier to work on when we're looking straight at the thing than me trying to crane over and lean over and not shock myself while I'm screwing around with all this stuff. Alright, a little bit easier to make those adjustments now with the right side up. Both horizontal and vertical hold are pretty twitchy. Vertical hold especially, it's basically impossible to get a lock. But the horizontal too, if I tune off and tune back on, the phase gets screwy. But
certainly progress. Well, not exactly the greatest viewing experiences, but we do have video. As I've said a million times before, when you use a test CRT, it's blurry because it doesn't like the electromagnet focus coil around the neck. So what I'm going to do next... Oh, by the way, also notice our vertical collapse problem is just gone. I don't know what happened with that. I'm going to pop the full-size CRT back in because that won't have the same focus issue, and I want to know how well does it work. So we saw in the tester it was a tad on the weak side. Let's see in practice how that plays out. So there is some next generation action. Manipulating the contrast now. And hey, this CRT has an ion burn. Or at least a discolored splotch in the middle there. That's not supposed to happen. Oh well. Part of the charm of these old sets. Now here's something kind of interesting. Adjusting the controls on that high voltage supply, and boy, I can see why you really need to follow the procedures for doing this, because it makes a big difference. So here's all the way to one extreme. It's just completely fading out. If I go the other way, the image shrinks and shrinks. There's two adjustments. This one has a smaller effect. Boy, I tell you, when everything's dialed in right, that looks pretty darn good. I think what's happening when it disappears is this feedback mechanism with a weak tube in there. Things are just spiraling out of control and it's not able to regulate.